force on the motion of a charged particle in uniform magnetic field. Motion of a charged particle in a uniform magnetic field. Actually, what happened? We saw that if a charged particle enter into the uniform magnetic field, it attains the force. That we go to see now. Consider this is a part. In this part, the crossed portion. This is said to be magnetic induction acting uniform magnetic induction acting inverse direction, that is into the board. This uniform magnetic induction is acting inverse to the board. Now, a charged particle, this is magnetic induction B acting inverse. A charged particle now enter perpendicular to the direction of the magnetic induction. The charged particle enter perpendicular to the direction of magnetic induction. So, if the charged particle is entering here, maybe you consider that positive Q charge is entered here. What actually happened? After entering that, it comes the Lorentz force comes. So the Lorentz force acts on the charged particle to make the charged particle rotate in the circular path. Rotate in the circular path. So the force acts in perpendicular direction. For example, if this is the direction of the magnetic induction, this is the direction of the magnetic induction, and this is the velocity of the particle. This is the velocity of the particle, this is the velocity of the particle. This will be the force. This will be the Lorentz force. Okay? If this is magnetic induction, this is velocity, this is Lorentz force. Okay, so both are perpendicular direction. So I told that the magnetic induction is in this direction and velocity is in this direction and the force is acting on this direction. So the force, Lorentz force acting inverse direction. This is the direction of Lorentz force. So due to the Lorentz force, the velocity is in this form. This is velocity direction. This is the direction of the velocity. Due to the Lorentz force, act on a charged particle, while entering into the magnetic field, it attains the circular path because of the Lorentz force. The Lorentz force என்ன பண்ணுது அந்த charged particle புடிச்சு இழுக்குது. இழுக்கக்குள்ள என்ன ஆயிடுது, அது ஒரு டைரக்ஷன்ல ஃபோர்ஸ் கொடுக்கக்குள்ள அப்போ சுத்த ஆரம்பிக்குது. நல்லா புரிஞ்சுக்கீங்க. A particle rotate in a circular path, definitely it has the centripetal force. அது கண்டிப்பா என்ன இருக்கணும், centripetal force இருக்கணும். அப்ப நம்ம இந்த சார்ஜ் பார்ட்டிகிள் மெயினா இருக்கக்கூடிய ஃபோர்ஸ் என்னன்னா அந்த லொரன்ஸ் ஃபோர்ஸால தான் சுத்த ஆரம்பிக்குது, புடிச்சு இழுக்குது. The Lorentz force effect is to know that Q into B cross B. Q into B cross B. But magnitude is F is equal to, you can write BQV sin theta. You can write BQV sin theta. Theta is the angle between the magnetic induction and the direction of the velocity. So theta is 90. Theta is 90. Now we can write F is equal to BQV. This is force, Lorentz force due to a charged particle. Sorry. Now if a body revolves in the circular path, it has centripetal force. So the centripetal force F is equal to, generally you can say mv square by r. Let r be the radius of the path. Let r be the radius. r radius, and m mass of the charged particle, v velocity of the charged particle, b magnetic induction given in the perpendicular direction, and q is the charge of the particle. If both the forces are equal, then only the body can revolve around the circular path. ரெண்டுமே சமமா இருக்கும். Then only the body can revolve around the circular path. So both are equal. We can write VQV is equal to mv square by r. Now cancel the v and v. Here v by r square cancel பண்ணிட்ட v by r is equal to bq by m. v by r equal to bq by m, or r is equal to mv by bq. r is equal to mv by bq. போடலாமா? r equal to mv by bq. You know the value momentum p is equal to mass into velocity. Momentum p is equal to mass into velocity. So r is equal to p by bq. r equal to p by bq. இது வந்து மொமெண்டத்துக்கு ரிலேட் பண்ணி நம்ம சொல்லியிருக்கோம். If a particle revolving in the circular path, we have to say what will be the frequency, what will be the time period, what will be the angular frequency. இதெல்லாம் நம்ம சொல்லணும். First, what is the time period? Time period சொல்லிட்டோம்னா இது எல்லாத்தையும் சொல்லிடலாம். What is the time period? So the time period t is equal to time period வேணும் அப்படின்னா complete rotationக்கு என்ன time period? இத கம்ப்ளீட்டா ரிவால்வ் ஆகும் அப்படின்னா that is 2 pi r by v, because velocity is equal to displacement by time. So velocity is equal to displacement is one complete rotation, that is 2 pi r by t. So in this we can write this r smaller. T is equal to 2 pi r by v. You know the value of r by v. Here v by r. r by v means you take inverse. So t is equal to 2 pi r by v means m by bq. 2 pi m by bq. This is time period of the rotation. Time period of the charged particle rotate in circular path. Okay. Time period of the charged particle rotate in a circular path. Now you can find the frequency. So what is the frequency? Frequency f is equal to 1 by time period is said to be frequency. 1 by time period is equal to what? You take inverse value bq by 2 pi m. This is frequency. Frequency means what? Number of per second how many rotations, that is frequency. Per second how many rotations, that is frequency. What is angular frequency? ஒரு பொருள் வந்து சுத்த ஆரம்பிச்சுச்சுன்னா, if it is revolve around the path, we can say the angular frequency. Angular frequency say omega. Omega is equal to general formula 2 pi f. Omega is equal to 2 pi f. 2 pi f, f you know, bq by 2 pi m. So 2 pi and 2 pi get cancelled. Now omega is equal to bq by m. Omega is equal to bq by m. Actually what happened? This is north pole, consider this is north pole of a magnet and this is south pole of a magnet. This south pole of a magnet. The magnetic lines of force from north pole to south pole. This is the direction of magnetic lines of force. Okay. Now a charged particle enter here. A charged particle enter here. What actually happening? According to our concept, it may be attain the circular path, but actually not happen. You see the equation, both frequency and the time period. ரெண்டுத்துல எங்கேயாவது velocity வந்திருக்கா? So the time period as well as the frequency and angular frequency both are independent of the velocity. இது எதுவுமே velocity டிபெண்ட் பண்ணி கிடையாது. அதே மாதிரி இங்க பாருங்க, இல்ல ரேடியஸ் இருக்கா பாருங்க, r எங்கேயாவது வந்திருக்கா பாருங்க. It is independent of the radius of the path. அப்ப இதெல்லாம் எது கிடையாது, ரேடியஸ் டிபெண்ட் பண்ணி இதெல்லாம் கிடையாது அப்படின்னு அர்த்தம். It is independent of radius of the path. As well as B, magnetic induction is not exactly say perpendicular to the velocity. இது velocity perpendicular நம்ம சொல்ல முடியாது. அப்ப என்ன நடக்குது? ஆனா perpendicular ஒரு வார்த்தை சொல்லிருக்கோம். So maybe perpendicular. So two component is acting between B and the velocity. The magnetic inductionக்கும் velocityக்கும் ரெண்டு component சொல்றோம். One is parallel along the direction of the magnetic field. The velocity component is divided into two. One is parallel component, another one is perpendicular component. So the parallel component which is act along the direction of the magnetic field, there is no change. And the velocity எந்த changesum கிடையாது. So the velocity along the direction parallel to the magnetic induction, no change. Now come to the perpendicular direction. If you are coming to the perpendicular direction, it may vary. It may vary. So that the velocity which is perpendicular to the direction of the magnetic field is not constant. So it attains a helix path. It attains a helical path. So that the charged particle now entering in the uniform magnetic field, it attains the path like this, a spiral path. எப்படி இருக்கும்? இப்படி போகும். A plus Q charge இருந்துச்சுன்னா the charge will be move like this. This is the path of the charge. If the electron is entered into the uniform magnetic induction, this thing will happen. Okay? You make a note of all this.